Good day, my dear students. Today I'm going to perform the activity ladder on the wall. This is in relation to right triangle trigonometry, in which you're going to find the measure of the acute angles of a right triangle, and also you can use the trigonometric function to find the sides and the hypotenuse of a right triangle. So to perform the activity, you're going to need the following materials. So, instead of a ladder, we're going to use this corrugated round bar. So instead of a ladder, you can use any tall object, preferably taller than you, or a stick that can lean on the wall. Okay, so you need a ruler. You can use also meter stick, pulpose rule, or tape measure. So a ruler is only 1 foot, equivalent to 300 millimeters or 30 centimeters. Okay, then you need a scratch paper for your recording, and then a ball pen. So you don't need a protractor to measure the angle, because we will solve the measure of the angle by using the trigonometric function. So the trigonometric functions are the sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so first, what you're going to do is you're going to lean the object on the wall. So in this manner. So here's the wall, the foot of the wall, and then the floor up to the tip of the object. Okay. So you can adjust the distance from the object. So for example, this is the distance that we're going to measure. So use a ruler, measure here. So we are going to use centimeters, so this is 30 centimeters from here. You have there 20, that is 27. So 30 plus 27, so that is 57. So we're going to record the distance from the foot of the wall to the tip of your ladder or object. So you're going to draw the illustration like this one. Okay. So 57 centimeters here. Then after that, we're going to find the length of the object. So if you have, much better if you're going to use a pulpose rule or pulgadira, so that it will be easy for you to measure. Okay, so there, about there. Okay, so we will mark here. So be sure that it coincides with your mark. So that's 60, 90, 120. So the length of the round bar is 144 centimeters. Okay, so this time we're going to find now the measure of the angle formed by the round bar to the wall from the floor. Okay, so but before that, we're going to draw or make an illustration. Okay, so this is the wall, represents the wall, this side, and this side represents the floor, and this side represents the round bar. Okay, so this symbols meaning it is perpendicular to the ground. the wall is perpendicular to the ground. Okay, so by measuring a while ago, we know that the distance from the wall to the tip of the round bar is 57 centimeters. And then also the length of the round bar is 144 centimeters. Now we're going to find the angle formed here, the angle formed by the round bar and the floor. And of course, we're going to find the distance from the floor to the tip of the round bar above. So to find here, we can only use the Pythagorean theorem. So the Pythagorean theorem states that the square of the hypotenuse C is equals to the sum of the square of the legs, or C squared equals A squared plus B squared. So that is our Pythagorean theorem. Pythagorean theorem. And then to solve for the angle, we're going to use the tangent function. So tangent theta is equal to opposite over adjacent. So the opposite is B and the adjacent is A. So we will write our given. So side A is 57 centimeters, B is unknown, and then C is the length of the round bar, that is our hypotenuse, 144 centimeters. And we're going also to find the angle theta. Okay, so first we're going to solve for C, solve for B. So using our Pythagorean theorem, C squared equals A squared plus B squared, then B squared equals C squared minus A squared, then B equals square root of C squared minus A squared. Then we will substitute. B equals square root of 144 squared minus 57 squared equals square root of 144 squared. 144 squared is equal to 20,736 minus 57 squared is 3,249 equals square root of 20,736 minus 3,249 is 17,487. So square root of 17,487 is 132.24 centimeters. Okay, so this is now the distance from the floor to the tip of the round bar. So it should be shorter than the length of the round bar. Next, we're going to find the angle formed by the round bar and the floor. Okay, so using tangent function, tangent theta equals opposite over adjacent. So B is our opposite and then A is the adjacent. So tangent theta is equal to, our B is 132.24 divided by our A is 57 or 57. So tangent theta equals, okay, so tangent theta 132 divided 0.24 divided by 57 is 2.32. So to find theta, we're going to inverse tangent. So tangent raised to negative 1, 2.32. So you're going to use your calculator, and the value is 66.68 degrees. So this is now the angle formed by the round bar and the floor.